Oh yeah, in this video we are going to go over how to determine whether or not data that is given to us is linear or nonlinear. So let's check that out. The instructions say determine if the data in each table represents a linear or nonlinear function. Just a quick reminder that data is just any observable amounts, right? So data could be anything from the number of times you've eaten ice cream this year to the number of frogs sitting on a log. I don't know. So in this case, we're just given tables of information, data, and we're asked to tell whether or not it's linear or nonlinear. To be linear means that for every x or input value, in this case it'd be t and c of t value, for every t value that goes up by a certain amount, the c of t value goes up by that same amount. So we're checking patterns here and ratios. Let me show you what I mean by that. Here, t goes up by 1 every single time. So I'm going to put little notation. And if something is linear, it goes up in a nice constant amount, right? Like this, make a nice line going up or down. It doesn't increase at a faster rate or decrease at a faster rate. It doesn't slow down or speed up. It goes up at a nice linear amount. So for every one that we go up, let's see how much we go up in c of t. So think of this as like an x value and a y value. Well, c of t goes up by 25. 60 minus 35 is 25. And 85 minus 60 is 25. So we go up by 25 there. Here, we go up by 25 again. And then here, 135 minus 110, up by 25. So we notice that for every one we go up in t, we go up by 25 in c of t. That represents a nice linear relationship. Think of them as x and y values. Over 1 in the t direction or x direction, up 25. And then nice and consistently over 1 and up 25. And you stay constant like that. That is a representation of something that is linear. When you go up or down by the same exact amount, adding or subtracting, when compared to the amount that you go up or down in the x direction. Linear. Now let me show you something that may or may not be linear. Let's see. So we're given these values. I put it in a horizontal table just to give you a different flavor of presentation. Oh, very nice. So the x values go up by 1 each time. 2 to 3 is up by 1. 4 to 5 is up by 1. 3 to 4 is up by 1. The y values, let's see how much they go up by. Do we go up at a nice constant amount? Well, we go up by 3, up by 5. Ooh, right away, up by 7, and up by 9. I'm just seeing what is the distance from this y value to that one, and so on and so forth. So for every one that we go up in the x direction, we don't go up by the same amount in the y direction. So this is non-linear. It will not make a line. It doesn't mean that it's not good solid data. It's just not linear. So you could also go down. So let me keep this in mind here. There's no reason why these can't all be negatives. And why these can't end up being plus a negative 25, where we're literally subtracting 25 every time. That doesn't make it any less linear, so just wanted to point that out. That's it, peeps. To determine whether or not something's linear or nonlinear, you take a look at the data, see what the gap is in between them, and see if you have a nice consistent going up or down amount. If you do, and you're adding or subtracting by the same amount, then you know that you have linear data. If not, it's nonlinear. See you in the next video.